Okay, we want to talk about systems of three equations in three unknowns. That's also a very simple lesson. I think the best way to do it is to start with an example. Okay, so we want to solve this system. So let me write example. Okay, I would say solve the following systems. Okay, so let me first start with a simple equation which is in the book. So the system is this. So number one, I have this system consisting of three equations. This is exactly a question in the book. So 2x plus y plus z, this is equal to 0. And then I have 2x plus 2y equals to 2. And then I have 3z minus y equals to 10. Okay? So you see that we are supposed to solve this equation. Here I have a system of equations. It consists of three equations, and we have three unknowns, x, y, and z. Of course, in the second equation and the third equation, there is only two variables involved, but in general, we have three variables, yes? Okay, before teaching you something, do you have any idea how we can solve the problem? Yes?
Substitution?
So, for example, can you elaborate more?
No.
Why not?
I'm not sure what steps you should take to minimize the unknowns.
That is no problem. But for example, if you don't care about optimization, doing it in an optimized way, how do you think that we can do it?
Well, okay. First, I see the y at the bottom that is alone, and so you can move that to the other side, and move the 10 to the right, the left side.
Yeah, exactly.
And so you have y alone.
I think this is actually the optimized way. That's very nice. So yes, so I think the idea is this. We choose one of these equations, whichever you want to, it doesn't matter. And you'd make up your mind about eliminating one of these variables. Of course, experience comes to your help in this way. So as Gustav is now experienced mathematician, so he actually chose the correct equation. So if I wanted to solve this, probably I will do the same thing. So I will go here. I will go in this equation, and I will try to, as you said, I move y to the right. It becomes 10 plus y, and of course I move 10 to the left. So finally I get y is equal to 3z minus 10. Is that right? Everybody happy with this?
Yeah.
Okay. Now the point is that you are not allowed to touch this equation anymore. You use it here. And then you go to the equations that you haven't used so far. Wherever you see y, you replace it with this expression that you got. Is that understandable? So what you need to do, you go to the first equation, you write 2x, but instead of y, you see, instead of writing y here, I put this expression inside instead. So it becomes, let me put a pair of brackets momentarily here, and then I have a z, and then I have 0 on the right. And of course, you know that every time it's better to simplify as much as possible. So let us simplify that. Do you agree that I can write 2x? How many z's you see? Positive 3z.
4z.
So it is 4z. And then hopefully you agree with me, it's better to move 10 to the other side. So it becomes positive 10. And usually, if this is possible to simplify, I always simplify. So I divide by 2. What happens? It becomes x plus 2z equals to 5. Agree?
Yes.
Okay, so let us keep this for future. So I hope that you see what is happening. I am I will be left with a system of two equations in two unknowns, and I already know how to solve that. When I solve it, then I will find two variables, I plug it back here, I will find my last variable. So that's the idea. So let us keep. So I use this equation, I got that. I use this equation, I got that. So there is only one equation left that I haven't used so far. So instead of y, I again put this expression in. So what happens? It becomes 2x plus 2 times 3z minus 10 is equal to 2. And we simplify this. So it becomes 2x plus 6z minus 20 is equal to 2. Yes? And what is best to do is to move 20 to the right. So it becomes this number plus 22. Agree? But of course, it is better not to stop here. What I do, I will divide everything by 2 to make it simpler. So it becomes x plus 3z equals to 11. Okay, so it is a little bit lengthy, but it is not difficult. Now what you see, let me write this is number 1 equation, and this is number 2. Now if I ask you, what do you see in number 1, in number 2? How many equations you see? It is clear, 2 equations, number 1, number 2. But the important thing is this, how many unknowns are involved in this new equation? 2, x and z, yes? And we already, if you have done your homework properly, at this point you know what to do, yes? You go and solve this system. You see, it is a little bit lengthy, and you can guess what happens if I have 4 equations in 4 unknowns. In principle, it is not hard, but it becomes more tedious every time, yes? Okay, so let me just do it. So it means that this is part of the solution. You set up a new system, but it includes only 2 equations, x plus 2z equals to 1. And then you have another equation, x plus 3z. Was it equal to 1? No, it was not 1. Why I wrote 1, I don't know. So it is how much? 5, yes? It is 5. And then the next equation is x plus 3z equals to 11. Again, now your problem is more or less solved because you are facing a problem which already know how to solve. You have 2 methods, eliminations, addition. So which one is better here? Addition is probably better by multiplying the first one by a negative sign. Do you agree? So if I take this one and multiply it by -1, what do I get? I get this new equation. So this becomes minus x minus 2z equals to minus 5. The other equation is x plus 3z is equal to 11. And hopefully you know what to do. We add them side by side. What happens? This minus x and that x are cancelled. And then I have 3z minus 2z is just simply z. On the right hand side, what do I have? I have 6. That's it. I found my z. Okay? And then what do? I don't go to the original equation. Still, I am not done here. I found my z. I choose one of these equations, which is simpler, and plug z here. I prefer the first equation for obvious reasons. So instead of x, I don't know yet, but instead of z, I put 6. On the right-hand side, I have 5. And then what happens? X is equal to what? Minus 7. Do you agree? Yes? And then when this is done, x and z are found, you go to your previous equation. Either, it doesn't matter, you choose one of these equations, any one of them will work. And you plug these numbers in and you find the third variable. Of course, in the second one, it is pointless, yes?
Can't you just plug it into?
Yeah, that is much better, of course, yes. That's my preference. I would prefer to put this here, yes? Because you immediately find y. So let me give a name to this. Let me put a star here. So then I can use a star, yes, I can use a star to find my last variable. Y is equal, so this is not a good idea here because this doesn't depend. Let me write it here. So this gives me, according to a star, I need to train myself here as well. So y equals to 3 times 6 minus 10. So what's the number? It's 8, yes? So now if I want to write the answer, so the answer is x equals to minus 7, and, so you know that this symbol means and, y equals to 8, and z is equal to what?
6.
What was 6, yes. So this is the answer to this problem. If I ask you how many solutions I got for this system, what is your answer?
1.
1. Please be careful. X, Y, and Z are not 3 solutions. All of them in a package is 1 solution. Yes? A solution to a system is not one number. A package of X, Y, and Z in total is considered 1 solution to the whole system. Is that understandable? So you are not saying that I found 3 solutions for this. No. You found 3 numbers for each one of these variables. So if someone asks you how many solutions are there for this system, you say 1 solution. Okay? Is that understandable? Yes? Let me also test this idea if it works, if you are patient today. So let me go to Geogebra. So okay, so can you read the okay, I have the equations here. So as I told you, I want to give you a geometric picture of what is going on in 3 dimensions. Each one of these equations that I want to type in, so by the way, this is also good to learn. So you go here, there is something called view. You go to 3D graphics, okay, and then let me get rid of 2D graphics. I don't need it here. So to make everything right. Okay, then I go here and I will type that equation, 2x plus y. So yeah, it is a little bit hard to do it with Apple Pen, but I will try to do my best. Oops. Now this is a strange, yes, because yeah, I have to put plus, and then I have y, and then plus, then I have what? Z equals to 6. So this is one plane, as you see. Yes.
Hold up.
So,
Equal to 6.
pardon?
Equal to 0.
Oh, so okay, I put equal to 0. What is written there?
You wrote 2x
Yes.
y plus z equals to 0.
Okay, so just please read it to me. So this is 0. Thank you.
Yes.
Okay, so now, yeah, so this is the plane. So you see, this one, of course, I cannot now show it like this. So you see that that blue one is the plane which represents this equation in a space. Is that understandable? So if you go to one more dimension, instead of getting a line, you will get a plane. Okay? And then if I write another equation, can you read it for me, Gustav? What is that?
The second one.
Yes?
2x plus 2y equals to 2.
2y equals to 2. Yeah, that one. Okay, so that is another plane here. So if I want to show it from different directions, you see these are the planes. So far, you see that they are intersecting. Can you see what is the intersection? Don't look at this gray one. Let me take the gray one out if I can. Let me see. Yes, I will also change the colors. So if you don't mind, let me get rid of the axis as well. We don't need the axis. So this is a plain one, and then I will change the color, one of them. Hopefully I can do this here. Setting, I go to colors. Let me pick, I don't know which is your favorite color.
Purple.
So purple, I don't know if this is good at purple. Okay, so now you see that I have this situation so far. So I have two, these are not lines, you see. So let me see if I can find, okay, so that is good. So I have 2 planes, they are intersecting each other. What is the intersection? Can you see what is the intersection?
Hell no.
Yeah, it is clear. What's the intersection?
No.
Yeah, it is clear. Intersection between the purple one and the green one. Can you feel it? Okay, if you cannot feel it, there is an instruction up there. Do you see? There is a cone up there with a plane. This means intersection. I choose that one. Then I click on this and click on this. Then you find the intersection. What's the intersection? Come on, you see picture? What is the intersection? Tell it to me.
A straight line.
A straight line. So a straight line is the intersection between these two. How many points are there in the intersection so far? Yeah, just tell it.
Infinite.
Infinitely many. Okay? But let me add one more. Can you read it to me? The last one.
3z.
3z minus y.
No, 3z
minus y
equals to 10.
Equals to 10. Okay, hopefully this number is okay. This is another one. Okay? So, yeah, just open it. Yeah, so now, what do you see in the picture? It's a little bit strange. You see, when we go to higher dimensions, it is hard to see what is the intersection. You might say that there are no intersections, but if I continue, there will be an intersection. So you see, when we go to higher dimensions, realizing the intersection is very hard to imagine. So I don't know, can you see there is an intersection?
Kind of.
Yes? Because the intersection between these two lines is the answer. Yes? Yes, it should be between three planes, but we cannot find intersection between three planes using GeoGebra. So what I do, I find the intersection between two planes, it becomes a line. Then I will take another plane, find the intersection, it becomes another line. Then I will find the intersection between those two lines. It becomes the intersection of all the group. So this is why I'm saying that solving this geometrically is much harder. What I want you to understand is what is going on when you want to solve this problem geometrically, which is not easy at all. Yes? So this is not probably, so I don't know, you see, there is one single point, you see, these two lines that you see on the picture, they are intersecting exactly at one point. That point is the answer that we found. I don't know if this is GeoGebra is capable of just showing this to me. Yes, you see? I just clicked on it. The answers are -8, 7, 8, and 6. So you see, it's more complicated, but it is understandable. Is that understanding? Is it understandable for you? So you see that point, if I ask you, do you see any one point? Let me also change the color of one of these. Okay, let me change the color here. So that might be it is better to see. Let me make it red. Okay, so you see that I have this situation now. I have three planes. I don't know, it is hard to visualize even for me, but you see that there is one single point that lies on all those planes simultaneously. So that is the answer to the problem. And when I clicked it, I was lucky. When I clicked it, you see, the answer is -7, 8, and 6. And these are the exact answers that we got by algebraic calculation. But algebraic calculation is superior because I can go to higher dimensions. I can imagine 4 equations in 4 unknowns. But if I want to draw it geometrically, I need another extra dimension. We need to probably wait for another life. Yes, yes?
Could I ask you, two planes intersect while the third plane doesn't? Is that an answer?
No, there is no answer. Yeah, that was my point. I wanted to show the picture here for you. If I can find it, I will show it to you. So that is the idea. That the idea is clear. It might happen that I have two intersecting planes, and there is another one which doesn't intersect. One of them is parallel to that one. There is no solution for the system. But these are very advanced topics. You don't need to be worried about that. But I want you to understand what is the meaning of this answer geometrically. It means that you found a point in in three dimensions, such that lies on all those three planes simultaneously. That is important. Yes? Yes?
So, for the purple one, if you write x plus y equals to 1, is that 2x plus 2y equals 2?
That is the same thing. Yeah. And I don't know why the book they have written 2x plus 2y equals to 2. If I want to give such a question, definitely I myself divide it by 2. But if you write this will give you the same geometric plane. That doesn't affect the plane. So hopefully you understand what's going on from geometrical point of view. Of course, this is completely optional, but I want you to understand it because it is not hard to understand. Yes, even though it is not written in the book. Is that clear? Okay. So now, let me go back and try to solve some equations for you. So here, I will write one equation for you, and I'd probably wait for you to solve it for me. Okay, so the system is this. Okay, so let me write it in this way. So 2x plus 3y minus z is equal to 24. And the other one is 4x. It might be a little bit lengthy. If you have your calculator available, it's much better. Okay, so 3z equals to 22. No, sorry, 6. And then 6x minus y plus 2z equals to 22. Yeah, before starting, let me confirm that I have written everything correctly. 2x plus 3y minus z. Yes, that's correct. Yeah, please start doing it yourself. Of course, you should know that this might be a little bit lengthy, but no worries. Just be patient and follow the steps. Okay, so assume that, by the way, you don't want to solve it, but someone tells you that these are the solutions. So you want to check if these solutions are correct. You don't need to solve it to understand are these solutions correct or not. What is your suggestion to understand the solutions are correct or not? Yes?
Put them into an equation.
One equation is enough?
Yeah.
Put
the answers into an equation to see if the equality holds up.
Okay, so if the equality holds up in the first one, let us check. I put 5, 4, and minus 2 proposed by Kajal about this. I put it in the first equation. Let us see what happens. 2x becomes 10, 3y becomes 12, minus z becomes positive 2. So when I add them, it becomes 24, which is correct. But is it enough?
I guess
Not, but I have to check it against the other equations as well. If it is successful in all of these three equations, then we accept that this is the correct answer to this problem. But if I checked it, I think it's correct. So let us do this one. If I put x here, it becomes 20, minus 2y becomes minus 8, 3 times z is minus 6. Is it correct? Yes, because 20 minus 8 is 12, minus 6 is 6, so that's also correct. And then we check this one finally in the last equation. 6 times 5 is 30, minus 4, minus 4 again. So it is also 22. So congratulations, so that answer is correct. So what I'm trying to say, if you know the answer, you don't need to check, you don't need to solve it. If you want to check is an answer correct or not, you can check it in this way. So definitely, if I start solving this problem and I don't make any mistakes, I have to come up with this answer. Okay. Okay, so let us do that. I myself prefer, for example, to use the first equation and eliminate z. Let us do this time this way. It doesn't matter, of course, probably. If you have done it in a different way, you don't need to clean it. So I will choose the first equation. I will move everything except z to the right. So it becomes 24 minus 2x minus 3y. And then I multiply both sides by negative 1 to make z alone. So this becomes 2x, and the other one becomes 3y, the other one becomes minus 24, yes? I just multiplied them because I told you that I'm always optimistic. I start with positive signs. So that's why I put 2x first, 3y second, and minus 24 less. Okay? And then what was the goal? It is a little bit tedious, I agree. You have to take it and put it here, be patient, and after it is settled down, you have to put it here and then solve a new system. So let me just do that. So what I am doing now, I am taking this z out and I will replace it by this. Okay, so I copy and paste these two parts, so it becomes 4x minus 2y plus 3 times that. So it is 2x plus 3y minus 24 is equal to 6. Let me write vertically this time. So it becomes 2x minus 2y. I multiply 3 inside. Okay, and I simplify. 4x and 6x is 10x. Minus 2y and 9y is 7y. I move 72 to the right. It becomes 78. Agree? So this is one equation. So let us keep it for future. Yes, so I don't know why sometimes it messes up. Okay, so now we go, what we have to do, I take again this package and put it instead of z here. So I copy and paste the first two pieces, so it becomes 6x minus y plus 2. Don't forget to put pair of brackets or do it in your head. And don't forget to multiply these two by all the terms. Okay, so this becomes 6x minus y plus 4x plus 6y minus 48 is equal to 22. If I simplify it, this becomes 10x plus 5y. I move 48 to the other side, it becomes 70. Okay, and I prefer to simplify in this case because it is possible to simplify. By dividing by 5, it becomes 2x, this becomes y, and this becomes 14. It's not mandatory, these things, but especially if you are doing it with hand, it is better to respect simplifications. Okay, now what I have to do, I go back here and now set up a completely new system, but this time the point is that my system only contains two equations in two unknowns. Yes? Okay, so now that is up to you. Decide what you want to do with this system. What is your preference here in that system?
Find an answer for y.
This is one way to do that, but I myself prefer to multiply it by minus 5, the lower one. Yes, do you agree with me? Of course, that's up to you. This is not something mandatory, but I prefer to multiply by minus 5 this equation. So what I will get, the first equation is the same, 10x plus 7y is equal to 78, and the other equation becomes minus 10x minus 5y, and when I multiply this, it becomes minus 70. And now I add them side by side, yes? So what happens here? This one and that one are gone. So 7y minus 5y is just 2y's, and then I have 8. And when I divide by 2, it becomes 4. So as you predicted, so your answer was correct. So y is equal to 4. And when I find my y, I go to one of these equations. Of course, clearly the second one is easier. I put 5 here and find x. So what I do, I would write 2x plus 4 is equal to 14. So this means 2x is equal to 10. And then it means that x is equal to 5. Yes? Yes? And now what I want to do, I want to go to my first equation that I wrote. I put these two numbers in this equation and calculate, and I will get my z. Yes? So let us make it a little bit smaller so that you can see. Now z becomes equal to, you see here, I have 2x, x is 5, so it becomes 10. And then I have 3 times y, y is 4, so it becomes 12. And then you see a minus 24 at the end. So what is the answer? Is minus 2. So z is equal to minus 2. Again, let me ask you, how many solutions did I get? How many answers did I get for this equation? Only one, yes? So I would write SWAR. So by the way, let me also tell you something. It's not hard to understand. People sometimes call about the solution set. When they say the solution set, you need to write it in this way. So let me write it with a different color, so it means it's optional, okay? The solution set, you have these curly brackets open and closed, and then you write the numbers 5, and this is convention, that the first one is x, the second one is y, the third one is z. So this is called the solution set. Yeah, I just want you to know about that. It's not mandatory, okay? But at this level, if you want to write, you would write x is equal to 5 and y is equal to 4 and z is equal to -2. So that is your answer to this problem. Okay, so let me just now, for example, is there a question here? Yes?
The solution set looks a lot like the domain of a function.
Yes, that's you're right. That's exactly, because domain is also a set. Yeah. Yeah, so let me now, I have already done that in Geogebra. I got these 3 planes. When I typed them, I got these 3 planes, so I'm just trying to learn myself. So you see, if I move it, I don't know, can you see there is one single intersection point? Yes? Do you see there is only one single? But if I want to do with Geogebra, what is the idea? Do you remember? You go here, pick this option, and then click on 2 of them. You get a line. So it means that between those 2 planes, I have a line. So remember this one and that one. And I will do the same thing, for example, between this one and that one. I get another line. So hopefully, if I have done everything correctly, I should be able to see that these 2 lines are exactly intersect at one single point. Is that understandable? And then if I can, I don't know, if I can exactly point to that, I should be able to get the answer. Yes. So the answer is 5, 4, and -2. Exactly. And you see that this the Geogebra is actually writing it like the solution set, of course, without those curly brackets. Yes? Okay, there are some things that I want to show before leaving this. First of all, Geogebra is capable of solving the equation, so you don't need to do it graphically. So what I want to teach you, go here. You let me close this view. This is the 3D view. Let me get rid of that. There is a called CAS, Computer Algebra System. So you go here, and then I want to also get rid of algebra. I don't want to have this in front of me. But the problem is that typing it with iPad is a little bit hard. So let me test this keyboard if it is working. So you see, when I write solve, yeah, you see there are a bunch of commands coming down. But the point is that this is the reason that I switched to Classic 5. It's crazy. You see solutions, forget about that. You see solution, solve, list of equations, and list of variables. Okay, so this is this command that you have to use if you want to solve system of equations. So the point is that typing it is hard here. You go there and click it here. It's okay here, but you need to, because it is called list of equations. Yes, do you have questions?
Does it mean that it gives you that answer, or that you have to put it in yourself?
No, the equations you put, but it solves and gives you the final answers.
So when it's in the brackets,
yes,
you have to put that information in for an answer to come up.
Yes, that's yes. So you need to. When I say list of equation in GeoGebra, as far as I understood, when they talk about list, you have to open curly brackets and close them. This is the meaning of list in GeoGebra. Okay, so that is the bad point. In Classic 5, it knows what to do, but you see, when I want to type curly brackets, it's very strange. It is still keeping list of equations, and then I have to clean that. It's a little bit annoying, but in Classic 5, when I press that one, automatically list of equation is gone, and I am ready to type. I couldn't solve this in this Classic one. If you find a way, please let me know as well. So what we do, for example, this is unfortunate. I have to clean all this mess here, you know. And of course, now let us put the equations here. So the equation, if you remember, was 2x, yes, plus 3y, 3y minus z, if I am typing it wrong, please let me know, equals to 24. And then you have to put comma. It means that I am writing the second equation. The second equation is 4x minus 2y, and then plus 3z, yes, equals to what? 6. And then comma, I want to find another equation. I want to type another equation, 6x minus y, and then I have plus 2z equals to what? Equals to 22. Am I right?
Yes.
So equals to 22, but you see, list of variables. What?
22.
Oh, 22. Thank you. So list of variables. Again, list means that you have to open curly brackets. Okay, so I go here. It is working fine, but when I put these curly brackets, again, list of variables, I have to clean it up. So this doesn't happen in Classics 5. Okay, but anyway, what are my variables here? The unknown variables are x, y, and z. So I list them, x, y, and z. But unfortunately, I have to go and clean all this. I don't know why this doesn't automatically set. Okay. And then what you do, you just simply go at the end and press enter. Yes? And these are your solutions. X is equal to 5. Yes? Y is equal to 4 and z is equal to -2. So this is also one way. This is of course superior than doing geometrically, because in geometrically you have to visualize where it is, but this is solving it, and it can be solved even for 4 equations in 4 unknowns, 5 equations in 5 unknowns. It doesn't matter. This is something that I wanted to show here, so you can use this, but be careful. This solve doesn't work in normal view. You have to go to CAS, Computer Algebra System View. Okay, so you have to choose that one, then this solve option is available for you. Yes?
Can we use this on the test?
No, but there is also, I saw that there is also a test version of GeoGebra. I don't know what does it mean. I have to check it. So it might be, it's like DG exam. Yes?
Yeah, exactly. Put it in digits and then we use it.
Yeah, so that's a very good option. If that's the case, then you cannot kill me about I forgot my calculator. Yes. Yeah, that's a good idea. Yes, I will try to fix it. Okay, so now this is one thing that I wanted to mention, not to show this, but let me go to the next page. If I remember it correctly, then I want to bring it up for you. So now this is something that I want to show you. Do you remember these are the possibilities? If I have 3 planes in a space, I have these situations. Yes? So you see that might be I have this situation. It means that it might happen all these 3 planes are parallel. Okay, if I ask you how many intersection points you see in this case, what do you say? 0. And you see below it, it is written no solutions. Yes? But what about this case? This is also one possibility. 2 of them are parallel. This one and that one are parallel. This one is intersecting both of them. And you get 2 parallel lines. Do you see?
Yes.
Okay, but if I ask you how many solutions for the system do I have?
0.
0 again, because there is no one single point which is simultaneously on all the planes. So again, no solutions. It might happen that I have these 3 types of planes, yes? So how many solutions are there? 0. You see, you're actually improving your geometrical points of view. Here, it might happen that I have 3 planes, but they are lying on top of each other. So how many solutions are there? Infinitely many, because any point there, so you see that there are infinitely many. And this is like a book, for example, the papers of a book. So how many solutions are there? Infinitely many. All the points on this line of intersection lies simultaneously on all those 3 planes. So I have infinitely many solutions. Okay, what happens here? This is the only case that I have one unique solution, and you will only face this problem in the mathematics 2C. Okay, so the only one that you have one solution, but you see, this is not all cases. This is just one simple possible case out of all these possibilities. Okay, so you have one unique solution here. So no solutions, infinitely many. And what about this one? 2 of them lie on top of each other. One of them is parallel. Again, I do not find any intersection point. 2 of them are the same. One of them is separate, but they intersect. Again, I have infinitely many solutions. But the point is that there are 3 possibilities again. This is very surprising and interesting. Do you remember when we had 2 lines? It were either 0 solutions, 1 solution. It cannot have 2 solutions. 0, 1, suddenly infinitely many. And the same thing happens in a space, yes? 0, no solutions, 1 solution, or suddenly infinitely many solutions. It is not possible to have 2 solutions. Is that clear? This is from geometrical point of view is clear, but from algebraic point of view is not clear at all, because in algebra you have 3 equations. You need to think about how the algebra will work in this case, which is not trivial. Okay? Is that understandable? Okay, so now this chapter is totally finished. You can start working on the problems I will write on a school stuff. I hope that this recording also works. The reason that I am putting these earplugs is I don't know, this is my idea if it works. Because if I write with pen, you will hear the tick, 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 tock, tock, tock on the pen when I am recording it by iPad. So hopefully this will help, because from my perspective, the sound of the pen is created here. So it should go here and be recorded. So at least it is much better. Hopefully it works. I don't know. Okay, no questions. Thank you for listening. Have a nice weekend. Just one moment.